Okay, guys. So let's start. I think somebody's okay. Let's start now. So if you have any questions, let me know. And to proceed further, I have a quick question for you. And the question here is that you have a network 192. So let's say 172.16.16.0/16. And my task is to convert that into /24 network. Tell me how many network bits are there? How many networks we can have? How many host bits are there? What are the host IP addresses? So guys, if we are comfortable what we learned yesterday, let's go ahead and target this question. Did you get my question or do you think me to repeat again? Hello. Guys, kindly acknowledge if you can listen to me. Jibu, are you on the call?
Yes, we can listen to you, sir.
Sorry, your voice was too low, man.
We can listen to you, sir.
Okay. So my question here is we are going to subnet this network into /24. So the number of network bits we have is how many? 32. Sorry, it's 24 network bits. How many networks we have? Equal to
Sir.
how many networks we can configure now?
Ah, là, c'est un gars. D'accord. J'ai oublié ça là. Je ne pas oublier. C'est ça le ça. J'ai oublié mon
I,
détail. Oh
can
là
you
là.
put yourself on mute, please?
Ça fait apporter mon ordinateur, oui.
So the number of host bits will be 32 minus 24, which is equal to 8 host bits. Number of usable IP addresses 2 to the power 8 minus 2 is equal to 254. Now today, if you are comfortable with the subnetting, then today either we can move towards routing or switching, depend upon your interest. So I'm comfortable with both. So let's see. We have one router R1 and then we have another router.
Kiran, just for the revision purpose, can you also show what networks can be created out of this? I understand it's 8 host bits, but as per IP perspective.
Okay, if you want to go with the IP perspective, then we can have 172.16.10.0/24 172.16.1.0/24, 172.16.2.0/24, 172.16.3.0/24. This network will go till 172.16.255.255. This network will go till
How is this 8 bits? When you say it should be only 8 hosts per subnet, right?
8 host. What I said. What is this? This is the total number of host bits.
Hmm.
So the total number of host bits is 8, and the number of usable IP address will be 254. So if you are going to do this, let's say
Oh, okay, okay. I think I got it. Yeah, no worries. Got it.
2 to the power 8 is equal to 256. If I'm not wrong.
Hmm.
So this will be equal to 172.16.255. Sorry, my bad, guys. 1.255. Similarly, this network will go till 172.16.255.0/24. So in total, if you count the total number of networks will be this. The total number of network will be this, and total number of host bits will be this. Now, guys, we have two things to do. Either we can go ahead with routing or switching. Depends upon your understanding. But the topic that we covered for the day, for this week and next week is switching. But if you are good, we can go ahead with routing as well. I don't have any problem to mold the syllabus. So let's say we have router 1. So router works on which layer, guys?
Layer
Layer
3.
3.
Layer 3, right? So we are talking about layer 3 today, or switching works on which layer?
Layer 3.
Switching
Layer
switching works on
Layer 2.
layer 2. So let's see an example today. We'll try to do some lab if my packet tracer is working. Let's talk about some packet flow and see if the lab we can do or not. Okay. Suppose I have a router. On this router, I have in this router I have two interfaces. Let's say this interface and this interface. So if I talk about this interface, then let's say we have 172.16.1.0/24. So let's say 10, and I have the IP address here is dot 1. Guys, give me a minute. Okay, guys, my bad. And on router 2, I have, sorry, on router 1, I have another IP address 172.16.2.1/24. And this is 172.16.2.10/24. So now tell me how these two IP address will communicate. For suppose I have this.
was not able to perform IP address.
Sorry, guys, your voice is hardly audible, man. I can't hear you,
I'm
man.
saying that I'm saying that 24 was not clearly written in the second IP address.
Can you please type on the chat, man? Yeah, I'm facing the similar issue, or is anyone else also facing the similar issue? I hardly hear him today. Hello? Okay. So proceeding further, if we have source IP as 172.16.1.0.10, the destination IP 172.16.2.10/24, what will happen? This will create a IP packet. And this IP packet, I have data, then I have source IP address, and then I have a destination IP address. Remember the OSI model? 172.16.1.10. 172.16.1.2.10. Now what will happen? This packet will be encapsulated into frames. What is a frame, guys? This is my IP packet. This is my IP packet. IP packet. And then I have a source frame and destination. This is my source frame. This is my destination frame. So what is the source frame here? Let's see, we have a source frame here is as A, call A dot A dot A dot A. What about the destination frame, guys? So in order to make a complete frame, what is the destination frame here? Come on. How we will find the destination frame or the destination MAC address? Sorry. Address. Correct. So we can go do it via the ARP entries. So what we'll do here? This PC, this server will send the ARP request. And this is your ARP request. ARP stands for Address Resolution Protocol. Means I have the IP address. Please share the MAC address with me. What is the IP address here? What is the IP address here? Is it 172.16.1.1 or 172.16.2.1? 10. What is the IP address we need to find the MAC address for?
2.10.
2.10. Okay. Okay, fine. Any other thing, man? Only 2.10 or do you think it's 1.1?
The source is 1.10, isn't it?
The source is 1.10, but what see if
Yeah,
this
we need to find out 1.1 then. Yeah,
by 1.1 because
because the
it is the
next stop is
gateway.
router.
Yeah, the next stop is the router, it's the gateway, right? So now what will do? It will do the ARP request. It will say, okay, man, I know your IP address. Kindly give me the I know your IP address. Kindly share me your MAC address. So what is the IP address here? 172.16.1.1 is the IP address, and the corresponding MAC it will say, okay, my MAC is B dot B dot B dot. So now we have the MAC address available. What will happen next? As soon as the MAC address is available, this device, this server or router, whatever it is, server or PC, it will have a ARP table. To check the ARP table on Windows, it's show ARP. Sorry, it's ARP. Just type the ARP command. It will display you the ARP entries. As soon as you have the ARP, this packet, this frame will be forwarded to the R1. What R1 will do? Come on, guys. What R1 will do? Remove the frame and check the IP packet. So what is the IP packet we have? This is our IP packet. This is our IP packet. So what is the destination IP address? If we check on the router, we have something called routing table. We have routing table, and according to the routing table, one 172.16.2.10/24 is directly connected. So let's say this interface is gig 0/1 and 172.16.1.10/24 is directly connected. Gig 0/0/0. So means this interface we have at gig 0 0, let's say this is. So what will happen now? The routing table, the router will check the routing table and see, in order to reach 2.10, I need to forward the packet to this interface. On this interface. So what router will do? Router will rewrite the packet, or the packet will remain the same. It will write the frame, rewrite the frame. So in the frame, what will have the source MAC address and destination MAC address? This is the packet. In this packet, we have a source MAC and a destination MAC. So what is the destination MAC and what is the source MAC here? Come on, guys, kindly respond. What
Sorry,
is the
what was
source
your
MAC?
question again? What was your question again?
Router 1 will decapsulate the frame. It will check the routing table and forward the packet to gig 01010001. Now, the packet will not flow, right? It will be converted into or encapsulated into frame. So now what will be the source MAC and the destination MAC? Correct. Somebody has answered in the chat. The destination MAC will be the MAC address of this device. And the source MAC will be the MAC address of this interface. Gig. Now, my question is how the router will come to know the MAC address of this end device? How router will come to know the MAC address of the end device? Any clues? Guys, is this session is not lucrative, means not comfortable with you guys, or you want me to teach it another way? I need interaction with you guys. I can't speak alone. Hello? Okay, if you like that way, it's fine. So it will learn the IP address through the MAC address to the ARP request. The router will send the ARP request to the end device, and the end device will respond with the MAC address of the of its MAC address. And then router will send the request to the end device. Okay, guys. Does anyone have any concern? I know nobody will speak, but does anyone have any concern, or we can take it to the next level?
Take it to the next level.
Okay. Now, the next thing I'm going to discuss here is, suppose this is router 1. This is router 2. And these are interconnected via cable. I have one end device connected here. IP address, let's say 10.1.1.10. IP address 10.1.2/10/4, and let's say this network as 192.168.1.20, 1.0/30. This IP address dot one dot 2. And this IP address is dot 1. Now tell me how this two AND devices will communicate. Now the communication, I want that PC2 can talk to PC1. This direction. So how do you think the packet or the frame will work? Guys, if you're planning for interviews, this question is very, very important for you. Kindly interact, man. Or if you have any concern, just ask the questions.
Need to configure default gateway in PC.
Default gateway on, okay. So first step, you're saying on PC1, default PC1 default gateway on PC1 default gateway is 10.1.1.1. Then what? On PC2 default gateway is 10.1.2.1. Correct? What else you need to do? You need to configure IP addresses on router 1 and router 2. Okay, and anything else? Static routing protocol on both routers. That we can discuss later on. But my concern here is everything is configured. Just tell me the packet flow. How the packet will flow, man? That is my question. Just take the, is my screen visible? Take the reference of this diagram. And tell me how this packet will flow here in this diagram. Just take the reference and let me know how the packet will flow between these two devices.
From R1 interface to R2? Or
Yeah, so the packet will be from our PC2 to PC1.
see, from here, see, it will first see it is that this one 1.0 is not belong to this subnet. So
Okay.
it will directly flow, this packet goes to this R1 interface.
Okay.
So from there it will exchange the MAC address. So
Okay.
so here check the route.
Okay.
So it will forward to R1 interface, 1.1 interface.
Okay.
So then the MAC, it will compare the MAC table. Then it will send it to destination PC.
So you are saying MAC table, right?
Yeah.
So do you think the MAC table works in router?
ARP table is there, right? ARP
Yeah.
table, first ARP table it will check.
Exactly. So if I'm going to elaborate that into steps, if I'm going to write in steps, first step is what? PC2 will create a IP packet. What is the IP packet? Source IP address 10.1.2.10.
So whatever you are writing is not visible.
Oh man, sorry. I really
Yeah.
apologize. Is visible now?
Yeah.
Yeah.
PC2 will create an IP packet. The source IP this and the destination IP is 10.1.1.10. Second step. This PC2 will encapsulate this packet into the frame. So what is the source MAC address?
PC NICAD is the source MAC address.
PC2 NIC address, MAC address. And what about the destination MAC address?
This one router interface MAC address.
It will send an ARP request. Hey man, I please share your MAC address. So the MAC address will be router 2 interface connecting to PC2. Third, PC2 will send the frame on wire to the R2. R2 will check its routing table to see where 10.1.1.10 is residing. Guys, I am a good or do you have any questions till now?
Good, sir.
Good, sir.
In fifth step, what will happen? R2 will know that to reach 10.1.1.10, it needs to send the traffic to R1 on its connected interface. And on this, it have R2, so it will send the packet to R2. Now, in order to send the packet to R1, what R2 will do? Again, encapsulate the IP packet into frame. So again, source MAC, DMAC, and IP packet. IP packet will never ever change. So what is the source MAC here?
R2.
R2. What is the DMAC?
R1.
R. Man, please provide me your R MAC address. So it's R1 connecting interface to R1 MAC address. Guys, so far so good or any concern? The traffic lands on R1 and it will decapsulate the IP packet, the frame, and look for the destination. So what is the destination? 10.1.1.10 connected to R1 interface, which is, let's say, gig 0, 0. Guys, so far so good or any concern? In 7th step, what will happen? R1 will send an ARP request to find the MAC address of PC1. PC1 will reply with its MAC address, and R1 will encapsulate. Guys, do you think it's fine or is it boring or interesting, guys? Kindly respond.
This is correct actually.
No,
So
no.
each step we should know about the packet flow.
Man, if you are appearing for the interview on the basis of CCNA, they will definitely target this area.
Okay.
So you should know how the packet conversion actually happening.
Yeah.
R1 will encapsulate again the packet into the MAC address. Sorry, my bad. Frame. So for that you need source MAC. What is source MAC?
R1.
R1. What is the DMAC?
PC1.
ಏನದು?
The traffic will land on PC1. Traffic will land on PC. And it lands on PC1. PC1 will target the reply to PC2. So this how the actual packet flow will happen on routers. If you know about it, then definitely half of your entry on the basis of CCNA is done.
In realistic example, there are switches involved before the routers.
Exactly. Yes, man. That is my next target area.
Okay, cool.
Okay. So right now we're targeting on routers. Now I will add switches in the environment as well. Opening new window and let's make it like this. This is my router.
Router also send the ARP request, sir.
Yes.
So will it be having the back table?
It will not have the MAC table. It will have the ARP table.
Okay.
Suppose this is your router 1. This have a route switch connecting to router 1. And then I have PC1. PC1 have an IP address of, let's say, 192.168.1.11. Guys, I'm hearing some background noise. This is PC2. And let's say it is also connected to same network. And this is your switch. This is your switch. This is the router. And the IP address is .1. Now tell me how 192.168.1.11 and 192.168.1.12 will communicate. Is my screen visible?
Yes, sir.
So with the help of which they'll communicate.
With the help of?
Sir, with the help of MAC address, it will communicate.
Guys, that I know, okay, it will communicate by the MAC address. Can somebody tell me in brief, in details, what is happening?
Suppose this one PC1 will be communicated through PC2. The
Mm-hmm.
first it will this one first there is no MAC address table actually.
Mm-hmm.
So first the source address will be NIC address of this PC1, and the
Mm-hmm.
broadcast is the FFF. It will fill in the frame. So
Mm-hmm.
it will broadcast the message. So it will spread across the switch ports.
Mm-hmm.
So again, once it receive the PC2 message, it again the same thing will happen.
Okay.
Source address is the PC2 NIC address, and
Mm-hmm.
it will broadcast this one across the switch port.
Mm-hmm. Okay.
So once table is formed, then you start communicating each other.
Okay. Fine. Anyone else have any requirements or something else in their mind? So let's start with PC1. You are correct, absolutely correct. Let's elaborate into one. On PC1, again, a packet will be formed. In this, the source IP address is 192.168.1.11. The DIP will be is 192.168.1.12. So the my question here is, will the traffic hits default gateway or not?
No, in that case, they don't need default gateway because they are in the same subnetwork, in the same network. And in my opinion, they need only destination destination address MAC, and they need to use only switch.
Okay. So first of all, what PC will do? PC will check its CIDR. So let's say 192.168.1.11/24. So what PC will see, okay, the destination MAC address, destination IP address, and my IP address are on the same network. So I don't need to go to my default gateway, and it will start creating the packet. As soon as the packet is created, it will form it into frame. So for frame, what do you need, guys? For frame, what do you need?
Source
MAC
MAC,
address.
destination MAC.
Source and
Source
destination.
MAC address, right? What is the source MAC address?
PC1.
What is the destination MAC address?
MAC
Okay.
address of PC1, but I don't know what is this address because we don't add any information about MAC addresses.
Exactly. So what we'll do? This PC will send the ARP request to switch 1, and it will say, hey man, give me the MAC address of 192, sorry, 192.168.1.12. PC1 will send the ARP request to switch 1. Then what do you think what will happen?
So it basically broadcasts them across all the
It
ports.
will broadcast.
Yeah,
Okay.
it broadcasts, but without this source PC, it means without PC1 because it sends PC1 sent information to ask to request about the MAC address of destination MAC address, and switch ask all of computers, all of devices, hosts, without this one which was which requested.
Okay, fine. So there is some twist that I want to explain you. The switch will not send any broadcast message because switch has its own MAC address table. Switch will broadcast only once, means when it need to form its MAC table. So right now, let's say it has a MAC table.
In case it does not has the MAC table, it will still broadcast, right?
Yes. So MAC will, okay, let me explain you in detail. This is the MAC table. So what switch will do? Switch will do two things. First step, it will add the entry of PC1 in its MAC table. First step. And if it's, and then the second step, it will see the, check the MAC address for 192.168. Sorry, MAC address of PC2. Now, if it does not find the MAC address of PC2, what it will do? A broadcast or an unknown unicast?
Definitely broadcast.
Okay. It will do the broadcast. Broadcast to what? Broadcast to all its switch ports with F, 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 and F, and F. Guys, if you don't have, I don't have the MAC address of this. What is the MAC address for 192.168.1.12? Now it will send the broadcast to everyone. The broadcast will be received by the router and by this PC2 as well. And this PC2 will respond with its own MAC address. PC2 will respond to its own MAC address. And switch 1 will update its MAC table. So what it will do? It will update its table and send the response to switch 1. Sorry, PC1. Now the PC1 has its own, sorry, PC1 has the source MAC address as well as destination MAC address. It will update the destination MAC address, PC2. Then what will happen? Frame will be created. The frame will be sent it to switch. Switch 1 will see the MAC address table and forward the request to PC2, and PC2 will send the response. Now my question for you guys is, broadcast will be sent only when switch has no information or no entries in its MAC table. Now suppose switch has switch has 48 ports, out of which switch knows about 30 ports. So do you think is it feasible to send the broadcast to that 30 ports as well?
No,
Then what will happen?
it will send only to the
Unknown
remaining node.
unicast.
So it will send the request
Unknown
to
port.
the 18 ports, right? What is this called? A broadcast or
Multicast.
unknown unicast? Come on, guys. I know it will be
Unknown
new for you.
unicast.
Yeah, it's unknown
Not
unicast.
broadcast.
It will be unknown unicast because switch has to create the frame for every ports. That is called broadcast. But switch has the entries for 30 ports. So what switch will do, instead of creating the broadcast, it will send unknown unicast to that 18 ports. There will be no broadcast again. Something new?
Yeah, for me, it's something new.
I know it's easy, but people will talk about only broadcast because they don't know about unknown unicast. The actual thing is unknown unicast, guys.
So when will happen unknown unicast?
Unknown unicast will happen only when the switch has the MAC table and switch has around 48 ports. Out of that, it has the MAC entries of 30 ports, not the 18 ports. So in order to send that request, instead of sending the broadcast, it will send the unknown unicast to that 18 ports.
That MAC address should be in the table, right?
Sorry,
That MAC address should be in the table,
which table?
MAC table.
It is the switch did not see the MAC address in the MAC table, right? Then only it will send the broadcast of the unknown unicast, right?
Yeah.
If it has the MAC address entry in the table, then why it need to send the broadcast and the unknown unicast? When the switch is booted, right? Suppose the switch is fresh or you installed in the network. On the initial stage, it will send the broadcast. But after the initial discovery, right? For example, switch has 48 ports. Out of 48 ports, switch has learned the information about 30 ports. Do you think it is feasible to send the broadcast to that 30 ports again?
No.
Then, in order to avoid that broadcast, it will send the unknown unicast message to the remaining 18 ports. So the broadcast will happen only once.
So unknown only particular that port only sending, right? It won't
Yes.
send all the port.
Exactly.
Okay.
So just to avoid any confusion, I'll get rid of it. It will be unknown unicast. So far, so good, guys. Boring, interesting?
Interesting.
Interesting, it's good.
It's good. Okay. So guys, let's take a break for 5 minutes. Then I will introduce the concept of VLAN.
So let's start the class.
Yeah. So I'm starting now. So there is one timer on the Cisco devices, which we called as MAC aging timer. And the default value is 300 seconds. Means the MAC address will remove the entry of any of the user within 5 minutes if it is not communicating. Did you get it? Or do you want me to explain once again? So the MAC aging timer is the timer that a MAC address will stored in your MAC address table if you are not communicating within this time span, then the entry from the MAC table will be wiped out. Got it? Or do you want me to repeat again?
You elaborate it, please.
Okay. Let's suppose you have some entries on the MAC table, right? And you left your office at around 6 p.m. And now your device is not making any connection to the network. Your laptop or whether your desktop, whatever it is. If it is not making any of the connection to the network for 5 minutes, the MAC address table will remove the entry about your device from it. And that is called
Got
as MAC edging timer. So the
will it increase?
it can be increased and decreased depending upon your requirement, but the default value is 300 seconds. So you can tune it, and it can be 10000 and 10 lakh seconds. So you can increase it as per your requirement. Now, a quick question, guys. How many broadcast domain and the collision domain we have within the switch?
I think single collision.
How many ports in the switch? That is that many broadcast.
Okay.
Each port on collision diamond and on broadcast domain, I think.
Exactly. Each port in the switch is referring to the collision domain. But one broadcast domain. Because why one broadcast domain? Because all ports are in same VLAN, which is VLAN ID
1.
1. What if you need to increase the broadcast domain?
Is it possible to change the VLAN 1?
No, you can't delete or create VLAN 1. It is by default. If you have done it in your environment, great. But in my life, I have not seen it.
It couldn't be. That's why.
That's what I'm saying. I have never, you can't delete VLAN 1, you can't create VLAN 1. It is always there.
But customize switch or some modification means you can create anything means in that switch we can do, because some you can take some chassis like they're mix up with this one multi-vendor switch like.
Yeah, correct. Yeah, this one correct, because you can use the Juniper switch. In that switch, there is no default VLAN. Whatever VLAN you want, you make it as a default.
Okay. So guys, I'm sorry, I don't know about Juniper, so I'm talking about Cisco. And thank you.
Why,
Great learning for me.
why I'm telling now, I am working on the Juniper. That's why I'm telling you, sir.
Okay. Sorry guys, I was not aware of it. Thank you for your knowledge sharing. Next time if somebody will ask me, can we create another VLAN other than one? Then I will say yes, it is possible. And it is possible in Juniper devices, correct?
Yeah.
Okay. Thank you.
Yeah, thank you, sir. Thank you.
Moving ahead, a single switch contains only single VLAN. Am I right?
Yeah.
What if I want to create virtual switches within the VLAN? Sorry, virtual switches within the switch. So each VLAN within the switch is referred to as a virtual switch. VLAN 10, VLAN 20, and VLAN 30. This is your physical switch. So how many broadcast domain do you think we have now?
4.
Why 4?
The VLAN 1 also is there, right? Oh, sorry, this
VLAN
3.
10, VLAN 20, and VLAN 5.
3
Three
broadcast.
broadcast domain.
3.
So now the maximum number of VLAN that you can configure in your environment is
4095 or 96.
96. 124096.
124096. But why? The answer is correct, but why?
That is the maximum. That's why we are creating.
Okay, fine, but there should be any
Some maybe it's a code or some decimal or binary. Maybe the
okay. Let me explain you guys. When you introduce a VLAN in your environment, it will enforce 4 bytes of header on your frame. In these 4 bytes, we have 12 bits for VLAN. And if you go from 2 to the power 1 till 2 to the power 12, it is 124096. This is the answer. If somebody will ask you the maximum number of VLANs you can configure, you are correct, 4096. And why so? Because of 12 bits of VLAN ID we have on the VLAN header. That is why.
Sir, sorry for disturb you. If any possibility is there, virtually we can increase the VLAN numbers.
No, we can't, because after VLAN there is another concept it introduced in the market called VXLAN, and VXLAN uses 2 to the power 12 till 2 to the power 24. You can't. This is the shortcoming.
Yeah, okay.
However, you can do some
Okay,
encapsulation
okay.
techniques, right? Q in Q tunneling and all, but that is not a feasible solution.
Okay, sir. Thank you.
Okay, guys. So now my question is changes for you. Okay. So the question here is, I have a router. I have a switch. I have a PC. And this PC wants to communicate with the server. Now the question here is, switch 1 this is PC 1, this is server 1. PC 1 is on VLAN 10. The server is on VLAN 20. Then tell me how this will communicate.
Through gateway, it will communicate.
Via
Gateway.
gateway.
Router we have to create. Router we have to create both the VLANs, sub interfaces VLAN.
And that what technology we called as?
Stick.
Router on stick?
Single on stick. Something is there.
Router on stick.
Yeah.
So here you need to configure. There is another thing we can call as, sorry, This is the IP address. 10.1.2.10/24. This is called creating sub-interfaces. So one for interface VLAN.
Sorry for this. There is a logical sub interfaces.
Yeah, sub-interfaces. So exactly, that's why I'm saying it's a sub-interface. It's a logical one, not a physical one. So what we are going to do, this interface, we are going to convert into multiple sub-interfaces with the help of VLAN ID. That is called interface gig 0x0, no shutdown, interface gig 0/0.10 encapsulation.1.1q VLAN ID 10. Now,
But
this is
nowadays, no one can use this.
we use, man. We use. I will
Oh.
tell you where. Okay.
Because everyone has L3 routers, right? L3 switches, right?
Exactly. That was my next question. Router on stick. But now we also use this, man. What you are saying, router on stick as well. I will explain you where. Okay. Instead, we can also have something called SVI. What is SVI?
Virtual
Interface. Switched
interface.
virtual interface. And this SVI is configured on L3 devices like L3 switches. So there is two concepts for inter-VLAN routing. One is router on stick. The another one is on the configuring the SVIs on your L3 devices. Gotcha?
Yes.
Yeah.
Yes. Now, the question for you means your answer that you asked from me, right? Suppose this is your CE router and this is connecting to your PE device. You know what is CE? P stands for provider edge, provider device. This is your customer end. Now you want to configure 3 VRF. VRF blue. You're going to configure a purple VRF. Let's say purple configured. Let's configure blue VRF. And let's configure yellow VRF. So for in connecting between C and P, they are not going to do any kind of L3 routing. What they are going to do, you will creating connecting a single interface, and that single interface you are going to convert into sub interfaces for different VRF. VRF A, let's say this is your VRF B, and this is your VRF C. Any question, guys?
Kiran, which scenario are you using this?
This you are using when you're connecting to your ISPs.
But in our ISP, we are connecting to directly for our firewall.
Firewall, no. Your firewall will be connecting to the internet.
Yeah.
It might be possible that on the firewall you have this VRF configured.
No, direct interface.
But I have seen a lot of people, means I have seen a lot of customers using this topology.
Maybe leased line?
No, not lease line, it's a MPLS, man.
Okay. I haven't worked on that. MPLS.
This is one of the good example of MPLS. But if you're talking about providers, they will be connecting your environment in this fashion. For sure. Okay. Are we good to proceed further?
Yes, sir.
Now, my next question for you guys is, I have switch 1. I have switch 2. On this switch, I have one PC, one PC2. So guys, today I'm talking about only scenarios. Next week, we can start the lab. This is your PC2. This
So
is
which
switch 1.
software are you using for lab?
We will be using packet tracer, man.
Okay.
Switch 1 and switch 2.
Can we do it all the practical?
Yes, we will. Even we will do the wireless as well.
Okay.
Switch 1, switch 2, PC1, PC2, access port, VLAN 10, access port, VLAN 10, IP address 10.1.1.10/24 and 10.1.1.11/24. Now tell me how to make sure this PC1 can communicate to PC2. They are connecting on different switches.
Actually, we are using trunking.
It won't communicate. There is no connectivity between switch 1 and switch 2.
Okay, let's have this cable connected. Now tell me.
So both are in the same broadcast. So this will be like a VLAN. It will connected VLAN 1 or VLAN 10?
You tell me what VLAN you will allow on this interface.
10.
Only 10?
Yeah.
Okay.
No, sir. By default, it make as a trunk. Whatever by default one is there now. We have to create one VLAN 10. In trunk port, whatever VLAN there in switch 1, in switch 2, it automatically forward. But same VLAN also create in the switch 2 also.
That fundamental is called as VTP. VLAN Trunking Protocol. But right now we're discussing about trunks. So in this one, what we're going to do, either we can create this interface as access interface or trunk interface. So now tell me, and I believe this will be the last question for the day. If I have MAC table here on switch 1, we have entries for VLAN 10. What entry for VLAN 10 for this server? Is it static or dynamic?
Dynamic.
And for 10.1.1.11, what entry it is? Static or dynamic?
Dynamic.
Why?
It will change, right? Once you connect the PC, then only it will update once broadcast happen.
Okay. Any other thing you can think of? Come on, guys. If that question is that much easy, I wouldn't have asked it. If I ask this question, means it's something to do with it. Come on.
We can configure static also.
But by default,
By default, it has dynamic only.
Okay. So first of all, guys, don't please correct me if I'm wrong. 10.1.1.10 is always static on switch 1, and 10.1.1.11 will be dynamic because it is learning via trunk, learning via another switch.
But here also same thing, right? PC1 also is dynamically update the MAC address, right? How we
But-
can say that static?
Okay, the switch 1 is learning that IP address statically, right? Because you statically configure the port in VLAN 10.
Correct.
But here, this switch is carrying multiple VLANs, man. So whatever the switch 2 will be having, the entry will be visible dynamically on the switch 1. So it's a dynamic.
Even switch 1 also same thing, right? If you connect the PC in the VLAN 10, the
Mhm.
MAC address will update dynamically only, right?
Okay, the MAC address will learn dynamically, right? Fine.
Mhm.
But how the device is configured? The interface is configured statically, man, on VLAN 10. When
Okay.
you configure this VLAN 10 on switch, right?
Mhm.
What command you use? You use interface F0 by 1 switch port mode
Mode
access,
access,
switch port
switch access,
mode access VLAN
VLAN 10.
no shut, and you're done.
Yeah.
What about this interface? How you configure this interface?
That one configure as a trunk.
Trunk. And all the entries that you're learning via trunk from remote device is always dynamic
Okay.
because
Okay.
it has a protocol called DTP.
DTP.
Dynamic trunking protocol.
Exactly. And that we need to disable by default. It is enabled by default, but we need to disable.
Can you please explain the difference between access and trunk? That's fine.
Somebody can please explain? Or I can explain. I don't have any problem. But if somebody knows about access and trunk, that would be great. Otherwise, I can explain. So, okay, if nobody is responding, access means you have only single VLAN allowed. Okay, means this port is part of VLAN 10. But if you're configuring trunk, more than one VLAN is allowed. Means more than one VLAN is allowed over that interface. Got it? Or do you want me to explain once again?
One second, please.
Sorry?
One second, please.
Okay. So here, if you suppose this is your interface, you want to configure it as trunk, then what do you need to do? Let's say interface F0/48 switch port mode trunk switch port trunk encapsulation dot 1Q and switch mode trunk allowed VLAN 10, 20, 30. No shut. Means this particular interface is carrying the traffic of 3 VLANs. That's why it is trunk. This interface is carrying the traffic of only single VLAN. That's why it is access. Where you need trunk? The trunk is needed on a device when you need to integrate with another network device, or your server or PC support multiple interfaces. If not multiple interfaces, at least multiple sub interfaces. Got it? Or do you still have any question? So whenever you are going to connect two switches together, you will always make them trunk. So guys, this is for the day. This is I thought to cover for the day. If you have any concerns, let me know. Otherwise, we can wrap up.
Kiran, in this course, what are the topic you are going to cover?
Man, I will be covering everything related to CCNA.
Okay, fine.
Okay. So routing, switching, then we'll cover something about basics of SDN, and then we'll cover something about wireless. That's it.
And the ACL also, right?
ACL, yeah. ACL will come, man. Definitely ACL will come.
Yeah. Okay.
Okay, guys. So I think we are good to close the call for the day. If you have any concerns, please park your question for the next week. If we are meeting next week, then.